and the achievements. Some of the things are really eye-opening for us. We didn't know that. So I'll now proceed to the second presentation by Dr. Sunil Singh on CSIR's contribution in Earth, Oceanic and Atmospheric Sciences.
Good morning. Next 15 minutes I'm going to tell the work which is being done by the scientists of CSIR working in the field of Earth, Ocean and Atmospheric Sciences. So here I will be talking about the work which is being done at National Institute of Oceanography and also part of the work which is being done at National Geophysical Research Institute, Hyderabad. So if you see just now our DG was mentioning, CSIR is working in all days of life, all sort of work being done. So what we have done in NGRI and NIO in the field of mineral resources, the ways in which we can improve the quality of life by providing the resources, exploiting them, putting the exploration on the land as well as in the ocean, how it is going to benefit these things in the life of everybody, common people. We are going to discuss about that. Okay. So we will start with this diagram where it summarizes most of the work which is being done in the Earth science field. So you can see here, this is the time when Earth got formed about 4.56 billion years, and then Moon formed after some time. Ocean came into existence about 3.8 billion years, and during that time oxygen was not there. The life which started was anaerobic, dependent on anaerobic metabolism. And it will be sulfate reducing bacteria were there, and at that time about say 2.8 or something like that, the cyanobacteria started the art of photosynthesis and started producing the oxygen, and because of that a lot of chemistry got changed. Before that the ocean was reducing, a lot of iron was present in there, different kind of metals were there, so life was very much adapted to that type of condition. And after the presence of oxygen, iron got oxidized, lost all the iron, and different kind of formation like binded iron formation and all those things got formed in the ocean, which are being used as a mineral resource. And then slowly oxygen started evolving, and then before that we are having prokaryotes life, prokaryotic life, then eukaryotic life started to come into existence, and then all these things happened. And oxygen was slowly starting in the ocean and getting consumed and slowly started to come to the atmosphere, and because of that oxygen layer, ozone layer got formed, and life started to begin on the land also. And slowly this oxygen at about 5.4 billion year, 5.4 million year, 540 million year time scale, oxygen suddenly shoot up at the present atmospheric level, and it is believed that multicellular life started during that time. So what we are trying to study, all these processes, trying to put the time scale at different process, and also how the processes have acted upon, how they have gone through. So we are trying to study all those things. Like in the beginning when Earth got formed, it was a gas and particle, the ball of gas and particles, high temperature, and when it started cooling, the Earth started fractionating, and we want to study how it started fractionating, when it started, what is the time scale of fractionation, and then when the ocean started coming into existence, what is the source of water, when it started exactly happening. So some of the questions we are answering in the subsequent slides. So here if you see the ocean, in the beginning there are a lot of hypotheses about ocean, how it started, whether it started from comets or whether it is from the different meteorites which came into impacted on the Earth. And whatever it is, there are many hypotheses about that, but everything accurate. And when Earth was degassing at that time, in the beginning a lot of CO2, helium, hydrogen and water vapor was coming into the atmosphere, and when it started cooling, this vapor started condensing, and that time we got the ocean got formed. And if you see the isotopic, move backward. Go in the beginning, please. Yeah.
Now we can visualize.
Okay. So there was a lot of discussion what is the source of water in the ocean. So people started doing different kind of isotope, oxygen isotope, and D by H ratio has been measured. And you can see here the ocean, which is about 155, 154, which is very much agreeing to the carbonaceous contact which has been measured, the meteorite which has been measured, and also the sum of the micrometeorites which has been found in the Antarctica. So you can see the D by H ratio of the ocean is very much similar to the carbonaceous contact and the Antarctic micrometeorite. So based on this, and if you see the comets which was supposed to be one of the source where, because they have a lot of water in that, they are much above this ocean D by H ratio, and based on that it has been concluded that most of the water in the ocean has come from this carbonaceous contact, not the comet. Comet can, if you see the mass balance, comet can supply about maximum 10% of the water. But the question was, when this process started. So you can see here, people have used oxygen isotope in the zircons. So zircons are the refractive, the mineral which is only available because you see all the sedimentary, all the rocks, the old rocks have been already obtained, their signature, whatever was there on the that, it has already been altered. So only thing which is available in the zircon mineral, which is very much refractory. So some of the zircon which has been dated and oxygen isotope has been measured. So zircon which is coming from the metal, they have this type of signature which is about 5.5, and that is all along it is there. But some of the zircon which is oxygen isotope is about 7 or 6, 5, more than 5. And this can be altered only because of water. So the earliest signature of alteration of those zircons, you can see here it has been found about 4.4 billion years back. So it is believed that the water, the presence of water on the earth, first time it has reported is about 4.4. So 4.4 water was already there, and since then ocean got found at 3.8 billion years, and then everything started. So if you see about Indian Ocean, now Indian Ocean is very much important. It's very unique basin, and in the sense that if you see Indian Ocean, unlike Pacific and Atlantic, this is bounded by land in the northern side. Because if you see the Pacific and Atlantic, it is both sides. It is going from pole to pole, but here it is bounded from by the land in the north, and it has many special features. Because of that, what is happening? The recent global warming, it is creating more. It is getting more heated. The Indian Ocean, and you see this is very unique basin in the sense that it is getting huge amount of fresh water and sediments from the rivers coming from Ganga, Himalaya, that is Ganga, Brahmaputra, Indus, Armen and all. They are supplying significant amount of millions of tons of sediment as well as huge amount of water, fresh water, and that is totally altering the signature of the sea water. At the same time, if you see huge amount of dust is coming from the nearby arid land mass in the Arabian Peninsula and all. They are again altering the geochemistry of the ocean and the biogeochemistry of the ocean. The two very unique features we have in the Bay of Bengal as well as the Arabian Sea is the presence of oxygen minimum zone. The oxygen minimum zone, generally if you see in the ocean, oxygen is abundant everywhere. It is directly in contact with the atmosphere, so oxygen are there. But in these two basins, if you go in the intermediate water column, the oxygen is almost going to the zero. Both the basins, Arabian Sea and Bay of Bengal, but the processes are different. In the Arabian Sea, what is happening? Because of southwest monsoon, lot of upwelling is taking place, and nutrients are coming to the surface, and productivity is more. And when this they are dying, it is going down, sinking, and all the oxygen is consumed in the intermediate water, and hence you are having almost oxygen which is zero, and it is part of the nitrate here is getting converted to nitrite, and because of that, the nitrogen which was supposed to be a nutrient which is supposed to be used for productivity is getting lost in form of nitrogen gases. So this is a very big phenomena which is happening naturally and which is affecting the nutrients of the ocean. If you see in the Bay of Bengal, there also we have oxygen minimum zone, but that process is very different. Because of the supply of fresh water here, there is the low density water lens is there on the surface, so water is not getting mixed, and because of that oxygen is not getting mixed along with all the water. productivity is there also. So because of that, here we are also creating the oxygen minimum zone, but the level is not that intense, and hence we are not converting nitrate to nitrite, and so the loss is not reported in this area. But there are recently some studies there where people have measured a very low level of oxygen there, and they are thinking that it is also going the way Arabian Sea has happened, and maybe in the future, if you continue anthropogenic activities continuing, this can also act as the consumer of means nitrate will be converted to nitrite and all those things. So, but still it is not confirmed. But if you see the other thing which is very much important here, the signal reversal of wind, and then current, because the southwest monsoon, during the southwest monsoon, the Arabian Sea water goes to the Bay of Bengal, and northeast monsoon, that is January, February, in those time, the Bay of Bengal water is coming to the Arabian Sea. So this is again because of this lot of geochemical activity, biogeochemistry is changing in this area. Another very important role of this Indian Ocean, if you see, is its connection with the other Indian Atlantic and Pacific Ocean. What is happening? All the oceans are connected with the conveyor belt, which is called global circulation. So what is happening in that global circulation? The deep water is forming at the northern poles, northern and southern poles, both of the places, and those deep waters are coming all the way in the Indian Ocean, like North Atlantic deep water and Atlantic deep water, and they are coming and then upwelling in this area, and part of that going to the Pacific, and Pacific some surface water is coming, that is called Indonesian through flow, and there partly it is coming to the Indian Ocean and leaving current through the Australia, and both these surface water again going back to the Atlantic by Agulhas current. So this is the whole circulation, and this circulation is very much important because they are redistributing the heat of the equatorial region. Whatever equatorial region more heat is there, excess heat is there, it is going to the polar region, and polar region coldness is getting distributed all over, and also the nutrient and oxygen. So this process is very much important, and Indian Ocean is contributing significantly to that. So this ITF is also important for our monsoon system, because the Indonesian through flow water, which is coming from the Pacific to the Indian Ocean, it is a warm and more saline water. So here, because of that, the amount of water determines the temperature between the south, the east and west part of the Indian Ocean, and that is called Indian Ocean dipole. So if it is getting changed, it will directly impact the monsoon. If more water is coming, this part will be warmer, and so Australia will get more rainfall, and that time this part will be cooler, and hence India will be dry period. It is less rainfall will be there, and opposite will be happening other way when the Pacific water is coming less. So this is again very important phenomena which our scientists are trying to study, how the water circulation is affecting the Indian Ocean dipole, and how the monsoon is changing, how it has changed in the past and how it is happening today. This type of work is being done. The another very important feature, if you see here, these mountains, you can see the mountain ridges within the ocean. This is called hydrothermal, the ridges. This is again very important because this is the place where the plate tectonics, new crust is forming in this area, and the entire plate is moving in this direction, and this entire plate is subducting in this part, Himalaya as well as this area where it is so Burma Sumatra area. And this is again, if you know, this part is the very much earthquake prone zone where a lot of stress building earthquakes are getting generated. So both NGRI and NIO are studying this earthquake prone area. NIO is studying this Andaman Nicobar, and NGRI is studying also. And also in that process, NGRI has invested huge amount of resources, and they have put all the seismometer along the Himalaya, which is supposed to be one of the active zone. And they are trying to see, because you have many seismic gaps on the Himalayas, so they are trying to see whether they can predict very important earthquake where it will happen in the near future. So that type of study is also being done. And here Andaman area and Sumatra area, the subduction is taking place. Again, this is a very hazardous area. A lot of earthquake is getting generated in this area. So both the institutes are working. They have put a lot of ocean bottom seismometer. The seismometer is sitting on the ocean bottom. They are collecting the data, and they found that there continuously seismic activity is happening, but the place where this 90-degree east is hitting this Andaman area, the activity is much less. So they believe that whatever data is shown, it shows that this area, right now we see the activity is less, the bottom topography is less, ocean bottom, but or probably the stress is getting built up in that particular area, and this could be a very disastrous earthquake come in the future. The time is not predicted, but hopefully that is the mechanism it is working like that. Another very important thing here in the Indian Ocean is the resources, which they talk about the different kind of resources. That is very much important for future, because all the resources in the land is getting vanished. We have utilized most of the resources. So people have to go towards the ocean to get some of the resources. So here if you see, we have in this area polymetallic nodule. As I was telling you, the water is full of oxygen, and we have dissolved iron in that. So in presence of oxygen, the iron will be precipitating at iron manganese hydroxide. So there is a coating is getting developed on the sea bottom, on the some particulate nucleation is happening, and huge amount of iron deposit is there. And since long time our NIO has worked in this area, they have found the huge deposit, and in about 75,000 square kilometer has been allotted to India by International Seabed Authority to do these experiments and do the mining in this area. And where it has been found that in that area about 100 million metric ton of the deposits are there in manganese, cobalt, nickel, and all those things are present. So that there again we have worked in that area. Still we are working, and we are trying to see if we are going to extract what kind of environmental impact it will have. So this is the area where again a huge investment of time and scientific manpower time, all these things happen. So the last thing I will tell you, another very important thing which has happened. In the coastal area, we have found the gas hydrate. That is the solid methane which is trapped within the sediment under 1000 water meter depth. And there again the huge resource is there. And as I was telling in the morning, if we are able to extract those gas hydrate, only the 10% of that, our energy requirement for the next 100 will be completely taken care. So these are again we have again both the institutes have worked on this direction. They have found the resources. Now under the blue economy or deep sea mission, the government which has started, they are going to be huge. Again investment will be there to how to exploit that technology is being developed in that. So in that case, we are also developing technology. We are trying to develop ROVs and how to go there, how to extract that. So this type of work is being done. So I will stop here. Thank you very much.
Thank you.